Hello students, welcome to Daily Chemistry Dosage. Here is another video for you which is related to molecular orbital theory. I am not going to explain MOT here. I will give you a super duper trick to find out the bond order. Trust me, if you know this trick, you can easily solve the questions related to the bond order within a fraction of a minute. So carefully watch the video. So before going to discuss the bond order, so the first and foremost thing you should do is, if any species is given to find out the bond order, you have to find out the total number of electrons in the given species. So this is the only step you have to do. If you know the total number of electrons in the given species, bond order is here and magnetic nature also in this table. Now the next question is how to by heart this table. It is not necessary to by heart this table. It is very simple to remember the table. I'll explain how. So let me take an example first, that is nitrogen molecule. So nitrogen molecule having how many atoms, how many electrons? So one nitrogen is having 7 electrons. Two nitrogen atoms are having 14 electrons, right? So you know that nitrogen is triple bonded with nitrogen. So what I mean is the bond order of nitrogen molecule is 3. Why? Because there is a triple bond. So what do you mean by bond order? Bond order is nothing but number of bonds between the atoms. Got it? So if you know this, the 14 electrons are there in a system, the bond order is 3. If you remember this one, you can easily write the table. So from the right side as well as left side, write down up to 8 to 20 electrons. 8, 9, 10, 11, 12, 13, 14, 15, up to 20 electrons. Okay, after writing the total number of electrons, fill up the column this first. That is 14 electrons having bond order 3. And coming to the right side as well as left side, so decrease the bond order up to 0.5. 2.5, 2.0, 1.5, 1, 0.50. Same thing with the other side also. 2.5, 2, 1.5, 1, 0.50. And remember one point here, this trick is applicable only for the species up to 20 electrons. Okay, if the species is having more than 20 electrons, there is another trick I'll explain in the next video. Got it? And one more point you should do is, you should remember the sequence. D triple P, DP. See here. DPP, DP. The same sequence repeats here. D, P, 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 DP. Last one is diamagnetic. So you know that D is dia, P means paramagnetic. Got it? Now let us discuss now how to solve the problems. So before that, there are 3 more important points. Please make it a note. Bond order is directly proportional to bond strength and bond strength is inversely proportional to bond length. That means if bond order increases, bond strength also increases. Bond strength also increases. And what about the bond length? It decreases. Got it? Now coming to the example, what is the bond order and magnetic nature of oxygen species, that is O2, O2 positive, O2 negative and O2 2 negative. Let me explain this. O2, O2 positive, O2 negative, O2 2 negative. Okay. So what do? We should find out the total number of electrons. How many electrons are there in oxygen atom? 8. 8 plus 8, 16 electrons. So in case of oxygen molecule, 16 electrons are there. So if 16 electrons are there, bond order is 2 and magnetic nature is para. Let us check it with the table. See, 16 electrons, bond order T, 2, paramagnetic in nature. Right? Now O2 positive, total number of electrons are 16 minus 1, 15 electrons. So for the 15 electrons, bond order is equal to 2.5. Magnetic nature is again paramagnetic. If you have any doubt, you can check it with the table. See, 15 electrons, 2.5 paramagnetic. Okay. Now coming to the next one, O2 negative. Total number of electrons are 16 plus 1, 17 electrons. So the bond order is equal to 1.5. Got it? And magnetic nature is dia. If you have any doubt, you can also cross check it with the stable. So 17 electrons, 1.5 para. See here. So I have written wrongly. Sorry, it is paramagnetic. Okay. For O2 negative, total number of electrons are 18 electrons. So bond order is equal to 1. And what is the magnetic nature? It is dia. So let me cross check it with the table. 18 electrons, bond order 1, diamagnetic. Got it? So see how simply we can find out the bond order and magnetic nature by using the trick, right? So this is the one type of question. And the second question is write the order of stability as well as bond length. So I have already told you a relation, that is bond order is directly proportional to bond strength and inversely proportional to bond length, right? So if bond order increases, bond strength increases, bond length decreases. So keeping the relation in the mind, you should note down the order here. So more bond order is 2.5, that is O2 positive is greater than O2 is greater than O2 negative is greater than O2 2 negative. This is related to stability, or you may say strength, bond strength. And what about the bond length? Simply reverse this order, that is O2 2 negative is greater than O2 negative is greater than O2 is greater than O2 positive. This is related to bond length. See how simply we can solve the questions if you know the table. Now, there is one more question here. What is the bond order of NO positive and NO negative? Here, 7 plus 8 minus 1, that means 14 electrons. So 14 electrons, 3 is the bond order. And here it is 14, 7 plus 8, 7 plus 8 plus 1. So it is 15 electrons. So bond order will be 2.5. So we very less time you can find out the bond order by using this trick. I hope you like this video. If you have any doubts related to this topic, please write in the comment section. Okay. Thank you very much for watching my video. This is Jyotsna signing off.